Hello everyone, welcome back to our chapter 4 revision for Sec 1 Science. So in this chapter, we are actually looking at separation techniques. And by separation, what we mean here is that we are using physical methods to separate mixtures. So everything that we are separating in this chapter will be considered a mixture. Now, if you have forgotten what are the differences between elements, compounds, and mixtures, please watch our previous video, which is on chapter 3, elements, compounds, and mixtures. So today, we will be talking about physical methods like filtration, distillation, chromatography, evaporation, and all these are physical methods that allow us to separate mixtures into their components. So let's start with the first method, which is magnetic attraction. Now, as the name suggests, magnetic attraction involves using magnets. And magnets can only attract magnetic materials. And our common magnetic materials are iron, nickel, and steel. So these are magnetic. And hence, these magnetic metals can be separated from other materials which are non-magnetic. For instance, metals like aluminium are not magnetic. Sand is not magnetic. So if you wanted to separate a mixture of iron and sand, we could just bring a magnet close to the mixture. The iron will be attracted to the magnet while the sand will remain inside the dish. So, in this little checkpoint question, you can see the diagram shows you how iron metal is a keyword because we recognize that iron metal is magnetic. So how iron metal can be recycled from waste. And this works because it's the iron metal, which is a magnetic material, it's attracted to the magnetic roller and therefore it is deflected into a different bin from the rest of the waste. Now, why might it be important to separate iron metal? Now, iron metal, like all metals, costs money to extract. In addition, to extract iron metal, we need to invest and put in a lot of energy. Now, as a result of that, the mining of iron metal is also damaging to the environment. So all in all, we have to separate out the iron from the waste so that we are able to recycle the waste. Okay, so that is magnetic attraction, our very first technique for separating magnetic materials from other materials which are not magnetic. And now, we shall move on to the next method, which is filtration. Now, filtration is a really common method of separation. In filtration, we are separating insoluble solids. The word insoluble means the solid cannot dissolve. And because the solid cannot dissolve, it will remain as a solid. Okay? So for instance, sand. If I put sand in water, sand is insoluble in water. It cannot dissolve in water. And hence, we can filter it out using this setup. So you must learn how to draw the filtration setup. The filtration setup includes the filter paper, filter funnel, and finally, whenever you draw filtration, always label where the residue will be and where the filtrate will be. So the residue is the insoluble solid. And the insoluble solid cannot pass through the filter paper. So it will rest on top of the filter paper. So residue rests on top of the filter paper. Whereas the filtrate will flow through the filter paper and be collected at the bottom. So you must be able to draw this setup as well as to label where the residue and filtrate is. Now, filtration is widely applied around us. It can be used to separate sand and water. So as mentioned, sand is insoluble. Because it's insoluble solid, the particles are too large. So it's about particle size. Particles are too large to pass through. Pass through what? Pass through the pores of the filter paper. Your filter paper has pores or holes, tiny holes that you cannot see with your eyes. Now, if the particles are insoluble solids, these will be too large to pass through the pores. Okay? Now, filtration works in many ways. For instance, when you are wearing a mask, your mask basically filters out all the dust, dirt, bacteria. When you are making tea with a tea bag, the tea bag itself acts as a filter that prevents the tea leaves from entering your tea. So only the compounds in tea which are soluble in water can enter your tea. Okay, so these are two very common examples of filtration. However, filtration alone cannot give us pure water from seawater. So imagine seawater contains dissolved salt. As a result of that, because there's salt dissolved in water, the salt is already dissolved, is not a solid anymore. So how then do you get salt? And how then do you get water from seawater? So now we go to the next few methods of separation. To obtain dissolved solids, like salt, we will make use of evaporation. So, evaporation is used to separate dissolved solids like salt from a solid liquid solution mixture. So the key word here is dissolved solids. They are in a solution. If I want to get back the salt, I will use evaporation. So basically, I pour the salt water into an evaporating dish. So this in red is the evaporating dish. And I pour the salt solution in and I evaporate it to dryness. Okay? So this can be done through heating up. If I heat up the mixture, it will be evaporated to dryness. And this is also how we get salt naturally from seawater. Okay? We can use the heat and the light from the sun. And that slowly heats up the seawater until all the water evaporates away, leaving behind these mountains of salt that you can see in the picture over here. Okay? So this is evaporation. Now, evaporation would not be suitable for solids that decompose. Now, some solids decompose or break down when heated strongly. So which solids will decompose? For instance, sugar. To obtain sugar from sugar solution, we cannot evaporate to dryness. This is because sugar will decompose to form carbon, black carbon, when it's heated too strongly. So for sugar, we have to obtain it by a different method called crystallization. Now you will learn about crystallization in upper secondary in Sec 3 when you do separation techniques again in your chemistry lesson. But for now, crystallization, basically just to introduce this word, is a method of obtaining solid crystals for soluble solids, meaning the solid is dissolved in water, but you want to crystallize it out as a solid again. And this involves heating the solution until it is saturated. Okay? The keyword here is saturated. Now, saturated is not dry. Saturated just means there is very little solvent left. So we heat it until there's very little solvent left, such that no more solid can dissolve. So we are basically heating up the sugar solution to a point by which there's so little water left that no more sugar can dissolve. And once you have heated it until it's saturated, that's the first step. The second step is to allow it to cool and crystallize. As you allow the solution to cool down, it will start to form crystals, and this process of forming crystals is called crystallization. And finally, the very last step, we would filter to collect the crystals. Okay, so this is an introduction to how we can use crystallization to actually obtain sugar crystals. Remember, sugar cannot be obtained by evaporation because it will decompose when heated strongly. Okay, now moving on. So we have covered to obtain salt from salt water, we will basically use evaporation to dryness. To obtain sugar, we will use crystallization. How do we obtain water then? Now to obtain water, we will use distillation. So distillation or simple distillation is to obtain water or the solvent from a solution. Okay? If you wanted pure water, you would use simple distillation. Okay? So the idea is to obtain your solvents back from the solution. And this is the setup for distillation. Now basically distillation involves two important steps. The first step is boiling. Basically the water will boil. As the water boils, it will rise up and enter the condenser. So the second step is condensation. So the water boils to form a gas, and then the gas condenses in the condenser to form the liquid. Alright, so there are two separate steps. Now importantly, we need to place a thermometer at the side arm. The side arm basically is this point. Alright, this particular point whereby the gas can go into the condenser. Okay, now the purpose of the thermometer is to measure the boiling point of the vapor. Alright, so in this case, if I'm obtaining water, the water's boiling point should be 100 degrees Celsius, meaning the thermometer's reading should be 100 degrees Celsius. Remember the unit, degrees Celsius, whenever you're writing this. It should be 100 degrees Celsius when water is coming out. Next, in order for the water to condense, we will need to pump cold water in. Remember, the water goes in from the bottom of the condenser and it exits from the top. In from the bottom, out from the top. Okay? Now you can see this is a very simple distillation setup. There are various functions of the distillation apparatus. For example, we will place boiling chips. Boiling chips help to ensure smooth boiling. Now this is particularly important because boiling can sometimes be very violent. When boiling happens, there's a lot of bubbles being produced. So if you do not have boiling chips, the boiling may be very violent. That could cause the glass flask to crack. Next, the thermometer, as mentioned, it measures the boiling point of the vapor. So if you are obtaining water, the boiling point should be 100 degrees Celsius. So the thermometer will read 100 degrees Celsius when it's water coming out. And finally, the condenser. As the name suggests, the condenser cools down, condenses the vapor. Condensation means from vapor it becomes liquid. Okay? So basically your water originally was a gas, now you condense it back down to a liquid. And that's how you get pure liquid water at the end. Now, this method works to give you pure water. So your distillate at the end is a pure liquid, pure water. Now this method works very well because there is only water and salt in seawater. So the water boils, but the salt doesn't. So it's water that's collected as pure water. However, what if there are more than one liquids which are dissolved into each other? Okay, for instance, what if there are two liquids with different boiling points? Let's say I mix water and ethanol. Now, ethanol is a type of alcohol. Okay, ethanol is a type of alcohol used in your hand sanitizers. So what if water and alcohol, which are both liquid, were mixed together? How will you separate two liquids, or even more than two liquids, which have different boiling points? Now, this is the idea of running a race, right? So water has its own boiling point, the alcohol has its own boiling point. Who will boil first? So the idea is we do fractional distillation when the liquids have different boiling points. Now, how do I know that this is fractional distillation? I know there's fractional distillation because I can see this wonderful apparatus called fractionating column. Now, in the fractionating column, you can see that there are glass beads inside. The moment you see fractionating column, it means there is fractional distillation. So how does this work? Let's say now we have water, and water boils at 100 degrees Celsius. So we know that water, boiling point, 100 degrees Celsius. What if you also have ethanol? Ethanol's boiling point is lower, 78 degrees Celsius. So comparing the two boiling points, who will boil off first? The substance with the lower boiling point will boil first. If it boils first, it will come out. It will distill out first. That makes sense. The lower boiling point is reached first. Ethanol reaches the boiling point first, and so it will boil off and be collected first. It's like a race. Ethanol will be faster to come out, to distill out of the mixture. Okay? So for fractional distillation, it is actually quite similar to simple distillation. The only difference, of course, is the fractionating column and the fact that now you have two or more liquids with different boiling points. Remember, the one with the lower boiling point will be collected first. Okay, the rest of the fractional distillation setup is actually very, very similar to that for simple distillation. And we remember our water for the condenser go in from the bottom, water out from the top. In from the bottom, out from the top. That is the direction of water flow in the condenser. So far we have covered magnetic attraction, filtration, evaporation to dryness, crystallization, and the two types of distillation: simple distillation, fractional distillation. Okay, so let's be familiar with when to use them before we move on to the last one. So let's go back to the start again. Magnetic attraction is really only used for magnetic materials like iron, nickel, steel. These are magnetic. So the moment you read iron, nickel, steel, we will use magnetic attraction. Filtration is used to separate insoluble solids like sand, stones. So long as you know that the solid is insoluble, cannot dissolve, it's filtration. And then we come to evaporation to dryness. For evaporation to dryness, we will use it only to obtain salt. Sodium chloride, salt. Other solids, other than salt, like sugar for example, we will use crystallization because we know that other solids like sugar will decompose when heated strongly. Now to obtain the liquid solvent, we will use simple distillation. And if there are more than one liquid, there are two liquids with different boiling points, we will use fractional distillation. So please ensure we are all familiar with the different parts, different apparatus used in the separation, when to use each separation. Now let's move on to the last separation technique, which is chromatography. Now chromatography is used to separate different dyes or drugs or colorings depending on the solubilities. So this is very crucial. To do chromatography, we must ensure that the colorings have different solubilities. Some are very soluble, they dissolve very well. Some are not so soluble, they don't dissolve so well. Alright, so we do paper chromatography by first taking chromatography paper and drawing a start line. The start line must be drawn in pencil. And importantly, this start line must always be kept above the water level when you do chromatography. Alright, so it's always kept above the solvent level. So this is the solvent. We dip the paper into a solvent. The solvent can be water, alcohol, or even other solvents. But the idea is the start line must be drawn in pencil and it is above the solvent level. Now, why is it that the start line must be in pencil? If I use pen ink, it has dyes which can be separated. It will create additional spots. Okay, remember that we are separating dyes and inks in chromatography. Your pen ink already contains inks. They can be separated by chromatography and create additional spots, which will interfere with your interpretation of the results. On the other hand, pencil. The pencil is insoluble, so it will not interfere with the results. Okay? Why is it that the start line must always be above the solvent level? Remember, on the start line is where you put your dyes to be analyzed. You have to prevent the dye from being dissolved directly into the solvent. You want your dye to dissolve slowly and move up, not dissolve directly into the solvent without moving up. If there's so much solvent, it's going to dissolve directly into the solvent. And therefore, we need to ensure that the start line is always above the solvent level so that your dyes can move up and not move into the solvent only. Okay? Now, moving on, how would you interpret chromatograms obtained? Now, this word chromatogram is another word for the results of chromatography. Okay, so first example, I have two dyes, one red, one blue, after separation. You notice, the blue dye is less soluble because it traveled a shorter distance, whereas the red dye traveled a longer distance. So the idea is longer distance, more soluble in the solvent. Shorter distance, less soluble. What if the dye doesn't move up at all? If the dye doesn't move up at all, it's insoluble. So doesn't move up means it remains on the start line. So if you see a dye that remains on the start line, then it's insoluble. It doesn't dissolve at all. So this is just based on the distances traveled by the dye. From the distances, greater distance, longer distance, more soluble. Shorter distance, less soluble. If totally didn't move up at all, remain on the start line, insoluble. Okay? So just based on distances. Next, example 2. After comparing different dyes, let's say on the same paper I separated 5 or 6 different dyes. How do I know which dye have the same components? To know whether they have the same components, we look whether they have the same spot at the same height. For example, X. X has the same spot at the same height as the red dye. Sorry, it's this particular spot. Same spot at the same height as the red dye. So X is likely to contain the red dye. Okay? Now, other than red, is there any other color that X is likely to contain? You can see that X also has this. It's the same as yellow. Right? And finally, which dyes are most likely pure? How do you know whether something is pure in chromatography? Pure means there's only one component, one substance. So those with only one spot will be pure. So of course, blue, red, yellow, they each have one spot. But to confirm whether something is pure, we will usually test their melting point. Because if they are pure, their melting point is fixed. That means it will melt or boil at a fixed temperature. So to test and confirm whether something is pure, we need to test the melting or boiling point, because if it's pure, it should melt or boil at a fixed temperature. Okay? And this really concludes how we can make full use of chromatography to analyze dyes, colorings, inks, paints, drugs as well. And please, let's be familiar with how to interpret chromatograms depending on the distance traveled. The distance traveled tells us something about the solubility. And finally, how to compare chromatograms of different dyes to see whether they contain the same components or not. Okay? Now, this set of notes can also be found in the One Respect, One Responsibility Science OneNote under the Content Library, Chapter 4. Content Library, Chapter 4, Separating Mixtures, right at the end, revision, chapter 4 notes. Alright, so for the one respect, one responsibility G3 science students, I hope you make full use of this to be revising for your end of year exam. Thank you.